Next we have inverses. Now what do you mean by inverse? Inverse means getting the opposite. Now in our case what we say we take some complex number a plus iota b such that it is non-zero. Why? Because we wanted to take the reverse of it. By taking the reverse, what do we mean? We mean that we wanted to calculate 1 plus a plus iota b. So that means this a plus iota b is coming in the denominator, and if something is coming in the denominator, we do not want it to be 0. So we restrict that it should be a non-zero complex number. One thing. Another thing, they are saying if you wanted to calculate the inverse, that means you wanted to calculate 1 divided by a plus iota b. So that when you multiply a plus iota b with this 1 by a plus iota b, you see this and this cancel each other, so that you have 1 as the final answer. So you call this number as some another number c plus iota d. So that means if you are able to find such number such that whenever you multiply it with the original number, you get back 1. So in that case we call this number c plus iota d as the inverse of the given number c a plus iota b. And by writing the inverse, for multiplication it is division, for addition the inverse is subtraction, and so on. Inverse means taking the opposite. So here the notation is that a plus iota b raised to power minus 1. So the inverses, they exist in complex numbers, right? So this is what this properties say, and we can calculate it. The method here is not discussed, how you are going to find the inverse. We'll be discussing it later on in the course. In fact, in groups we are just talking about closures, associativity, finding the identity element, and finding the inverse. So this is one of the property of groups that you will be studying later, right? Next, let's discuss powers of a complex number. Suppose you are given some complex number a plus iota b. So obviously, you know, in polar form you could write it like this: r cos theta plus iota sin theta, right? So now if I say that calculate the nth power of this complex number, so that means I am asking you to calculate the nth power of this complex number. So that means it would be equal to calculating the nth power of this thing and nth power of this thing. So it is of okay to us. Why? Because r is some real number, you can take its nth power, it would again be some real number. But how will you calculate the nth power of this term, this cos theta plus iota sin theta? So for that we have de Moivre's theorem, which we are going to discuss in 1 or 2 videos later, right? So according to that theorem, this thing come in the angle. So according to that, you see, we can write this thing here like this. So you could write a plus iota b raised to power n as equal to r to the power n cos of n theta plus iota times sine of n theta. So this is the result. And for radical means the rational power, 1 by n power. In that case, the power would be r to the power 1 by n, and again this power would come in the angle here. So it would be cos theta by n plus iota sin theta by n. So we can see various examples for this thing. So let's have a look here. For all the properties, let's quickly have a look. How do you add two complex numbers? So you have first complex number, second complex number. For adding, you see, you just add 3 with minus 5, that is minus 2, and you just add 5 with the 2, the complex part, that will give you 7. So this is the final answer. For the second example, we wanted to multiply these two complex numbers. So how do you do that? If you see at the formula, here we have AC minus BD as the first entry and AD plus BC as the second entry. So you know, this is A, this is B, this is C, this is D without the signs, right? Including the signs. So that means you will be calculating this thing here. It would be AC minus BD, right? So you solve this thing, you have this, and finally you have this, and then you have AD, right? AD plus BC, right? BC. So you can solve this thing, you have this, and you have this as the final answer, right? This is how you perform multiplication. Similarly for division, we'll again go back. For division, either you again perform this rationalization. That means you take the conjugate of the denominator. You have this number present in the denominator, right? So instead of iota, you are taking minus iota, so this term would become minus 7 iota, right? So you are dividing, you are multiplying this minus 2 minus 7 iota both in the numerator as well as in the denominator. No issue in that. So in the denominator, after multiplying these two terms, you will obtain the square of these two terms added, right? And in the numerator, you have to multiply these two terms. So again, you can apply the rule for multiplication. So it would be this thing for the real term and this thing for the complex or imaginary term, in a similar way that we have done in example 2. So after calculation, you will be getting this number, right? You can check your calculations using the given formulas. Next is calculating the product of the complex number and its conjugate. So when you multiply them, you will be just squaring both the numbers and then adding. So you get this as the final answer. Next, you wanted to calculate the inverse of this function. So you have to calculate 1 divided by this number. So you see, you have this number in the denominator. So what we do? We firstly take its conjugate. So that is 3 minus 5 iota in the denominator as well as in the numerator. And then we perform this calculation, multiply the number with its conjugate. We have this thing, and we can solve it further. So this is there. So this is the final complex number, right? And lastly, we wanted to calculate the powers of complex number and the radicals of complex number. So for that, we first of all have to convert the given number into the polar form. Let's see how we can do that. If this is the given complex number, we can write this is in this form, a plus iota b. So what is your a? A is 3 and b is equal to 5, right? So you see here, you can write this complex number in this form, r cos theta plus iota sin theta. So basically your r cos theta is equal to 3 and your r sin theta, that is equal to 5. That is known to you. So your tan theta is obtained when you divide sin theta by cos theta. So you could write r here, you can write r here. So the value of r sin theta, that is equal to 3. The value of r cos theta, that is equal to 5. You can substitute it here. So from here, what is the value of theta? It is tan inverse of 3 by 5. So this is your theta. Or you have tan theta is equal to 3 by 5. From here, you can calculate the cos theta and sin theta. So when you calculate it using the this Pythagoras theorem, you have cos theta as 3 divided by square root 34 and sin theta as 5 divided by 34. This is one thing. Another thing that we require for polar form is the value of r. So you know r, you know what is the formula? R square is equal to a square plus b square. This is the formula for r, right? So what is r? Square root of a square plus b square. You just have to substitute the values here and calculate the value. Once you have r, you can substitute this in place of r, and then for cos theta you have this value, for sin theta you have this value. And now you wanted to take the powers here. So you wanted to calculate the power 4 of this complex number. So basically we are taking this power 4 of this complex number as well. So that means you will have r raised to power 4, and here 4 will come in the angle. So it would be 4 theta and 4 theta. And when you wanted to calculate the radical power, it would be r to the power 1 by 4, and this 1 by 4 would come in the angle of this cos theta and sin theta according to De Moivre's theorem that we'll be discussing later on in this course. So I hope you understood this basics about complex numbers, right? If you wanted to learn more about it, you could just consult your previous books regarding this. So thank you for watching this video.